Hi students, welcome to HSC Earth and Environmental Science and Module 8 on Resource Management. This is video number 5, the second in our little series on mining and rehabilitation. This time we're going to focus on underground mining. Our learning intention is to investigate how mining sites affect the environment, including Aboriginal cultural sites, and examine methods of reclamation of the environment and those sites after mining operations cease. And this time, as I said, we're going to focus on underground mining methods. Underground mining is again something that we looked at in our Year 11 course, and we looked at things like room and pillar and longwall as examples of underground mining. Now, the consequences of different types of underground mining and the way that they are set up can also have some environmental implications, both during the time that the mine is in operation and also afterwards when these rehabilitation processes need to kick in. So we want to have a little bit of a look in this video at underground mining. There are a large number of environmental risks associated with underground mining. Just the very fact that you're going underground already increases the risks to the individuals that are involved or employed by the mining company. How much reinforcement occurs is often going to relate to the type of underground mining. For example, room and pillar mining has a lot more money and effort spent in reinforcing the roof so that there is a little bit more, integrity in terms of how long that roof is going to remain in place and support all of the rock above the actual area that's being mined. But if you're looking at longwall, then those roofing supports tend to be a little more temporary, and in either case, over time, they can start to break down. We get something called mine subsidence, and there's actually a mine subsidence New South Wales, which actually monitors and identifies. And if you're ever going to be buying a house, one of the things that should come up in your search is whether or not the land that you're building on is going to be affected by mine subsidence. But in addition to the actual type of mining itself, there's a whole lot of things that relate that are very similar in a lot of ways to the sort of things that we looked at when we were looking at open pit mining. Now, obviously, there is a difference between the processes of extracting the key ores, or at least the rocks that contain those key ores. But once the processing occurs, once the refining of the rocks starts to take place and the refining of the desired minerals or the metals, for example, that might be within those rocks, you're going to end up with some of these similar sorts of things. So we've got tailing dams, which can affect, a lot of these can affect groundwater if it seeps down through the layers. Surface water, obviously when it rains, it can dissolve some of the materials that have been now brought to the surface and wash them away, take them away from the site of the mine, but also leach them into the soil as well. Sometimes we have air contaminants, things like dust from waste rock and tailings as they're being crushed, can also enter the atmosphere, and so that can be a source of contamination as well. There's a whole lot of things here that are part of the whole process. But I guess if you think about the fact that we've got to actually get the rock out, which often involves explosions, we need to crush that rock, which can create a lot of dust. We're not going to keep all of that rock because we're going to identify the specific types of materials that we need from within it, the certain ores that are going to be able to be economically viable. And then we still, after that, often need to further reduce that ore into a specific metal, for example, that we're going to get from that ore in order to be successful in our mining processes. So there's a lot of things that are part of the environmental risk management that comes with the processes of mining generally, and a few of those which are exacerbated, I guess, by underground mining. When we're talking about water emissions, and waters are often used to make these sort of slurries that can be part of separation processes, and so radionucleotides, in particular thorium and uranium, can be part of the emissions in water. And remember, things like this or heavy metals only need to be present in very, very tiny amounts, and we're talking about ppm, parts per million, or sometimes even parts per billion, and yet still can cause health implications for humans and also for other living things, plants and animals in the area. Acids is one of the problems because acids can be used in the separation and refinement processes, and fluorides too. In the air, same sort of thing can happen with those radionuclides or heavy metals, but also a couple of the gases that can also be released during the refining process. smelting processes, for example, like sulfur oxide, sulfur dioxide, sulfur trioxide, can also create problems in terms of environmental pollution in the air, as well as increasing acid contents of surface and groundwater. So one of the ways I think of getting a good handle on each of these different types of mining methods and the sorts of rehabilitation or reclamation that we do with each of them is to look at a specific example of each. And I've just picked the Ottery mine, which is sort of just slightly north of Emmaville, sort of somewhere between Glen Innes and Tenterfield. This was an old arsenic and tin mine. It was operational in the late 19th century, and it has a number of different sources of contamination, including obviously arsenic. That's one of the key desired products of the mining process. So at least there's a lot of arsenic in there, but also other metals that were present, acids, which are often used in the process of trying to refine the metal ores and get them to try and recover the metals from them, and also metalliferous drainage. Very difficult when you're dealing with metal ions to be able to extract all of the ones that you actually want and not have some of them remain in some of the waste waters that are going to then go wherever they go. So we also have problems with residual mining waste. So the waste rock dumps, remember we talked about the fact that the desired mineral or the desired ore is not usually 100% of the rock, so therefore we've got to get rid of a lot of the waste rock that we don't want. We've got to put that somewhere, and sometimes that goes back in to refill our mine once we finish, but not always. Some of the tailings, so remember the tailings are some of these leftovers from the crushing processes, from some of those separation processes. They've again got to be stored somewhere. The slime dumps, which is basically now the wet slurries that are being created. And the problem with arsenic is these salts coated the old Ottery refinery and also the local areas where a lot of the processing was occurring for the products of this mining, of this particular mine. In addition, being an underground mine, we had several adits. So adits are the horizontal ones, and shafts are the vertical ones. So both adits and shafts are present throughout the mining site, and of course these are potential accidents waiting to happen, holes in the ground that you can literally fall into, but so can some of the animals that live in the area as well. So even just being able to seal these up is one important area of rehabilitation that has to occur in order to try and counter some of those potential problems. Having said that, a lot of work has been done in this area in order to try and rehabilitate what's been going on. So shaping of these waste rock or mullock dumps, some fencing and signing was also put up around the arsenic treatment plant. Obviously, there's still a lot of residual arsenic and arsenic salts in the area. Some partial covering of the slime dumps. There was repairs that were done to the dam wall, which was basically an area right near the tailing storage facility. Safety mesh placed over those mine shafts and stopes to kind of try and minimize the chances of people or animals inadvertently falling into these mine shafts. Also, some revegetation trials were happening on the slopes below the arsenic treatment plant. So we have quite a range of different rehabilitation works that were trying to counter some of the damage that the mining over many years had done to the environment. I think it's worth trying to have a look at a couple of these case studies as you look at each of these mining methods, just so you have something a little bit more precise, a little bit more specific that you can write about if you're asked questions about the rehabilitation process, particularly if you're asked to make comparisons between different types of mining processes, the potential damage that could occur to the environment and the rehabilitation processes that have occurred as a result. Certainly we're seeing a lot of areas now where the process of mining and rehabilitation has come a long way since the mining that occurred in the 19th century. And we're seeing some really positive things that mining companies are putting back into the environment once the life cycle of a mine has ended. We still have one more to look at. We're going to have a look at drilling, onshore and offshore drilling, and some of the environmental consequences and rehabilitation associated with those. And we'll do that in the next video. Thanks for watching.